couple different things I'd like to walk through and then turn you loose. Now, one of the things I want to discuss, this idea of fractions and whatnot, okay? So, one of the things is, if they were to give you, a graph and you had to like try to match up something. So this is one of the questions that was brought up yesterday. Something like this. Okay, I'm just going to give you some numbers here. Let's say that these were the numbers, okay? To match this up, to get a formula that goes with this, it's as easy as knowing what your X-intercepts are and knowing what type of function you're dealing with. Then we can adjust, if they are very specific, if they told you a Y-intercept, we can adjust the problem. And I showed you a very easy shortcut for that yesterday. I want to clarify that today. So, if they wanted to know what cubic function this one would be, a cubic function, that's something with a cube on it, right? It's something. There's 3 X-intercepts, that's kind of what it tells me, and plus it turned directions twice. So if it changed directions twice, that means it has a power of 3 on it. It's 3 minus 1. Turning points is how many, the power minus 1, right? Here's the trick. What are my parentheses that represent these X-intercepts? Well, this X-intercept, let me give you the numbers. This is -1, 0. This is 4, 0. And this one is 2, 3, 4, 5, 6, 7. -7, 0. So what are the parentheses that represent those numbers? What would make
X plus 1? I mean 7.
X plus 7. Okay, let's do that.
Oh, and X plus 1.
Okay. X plus 1. Okay, keep going.
X minus 4.
Okay, good. Stop there. Do we understand that those parentheses would give me those X-intercepts if you were to factor something apart? Okay. There's no horizontal limit, so it's probably not a fraction. In this case, there's no limits to this thing. So this is probably what it is. Now, if you were to FOIL this out, it would give you a cubic function. Does that make sense?
So yeah.
No, you don't have to. Because, here's the idea. I know you could FOIL it all out, it would be something x cubed, blah, 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 and in the very end, it'd be a -28. Does that make sense? Now, how I know that is because I know in the end, if you were to FOIL, the 7 times 1 times the -4 will be the back number. So I know roughly what would be in the middle, but I'd have to FOIL it all out. Does that make sense? Now here's the thing. What is my Y-intercept? A -2. Well, if I just left the formula where I have it right now, my Y-intercept would be -28. Because you'd plug in a bunch of zeros into all my X's, and your answer for the Y-intercept would be -28. So what I would need to do is shift this thing up how many spots? Because right now it's at -20. I need to go up 26 spots, right? Just add a 26 to the bottom, or the back. If you add a 26 to the back, it literally shifts it up 26 spots, and it will hit -2. Now, I believe you only have to do that on one of them. There was another one, they didn't really tell you the Y-intercept. You didn't have to worry about shifting it, because they weren't specific, and I didn't care what that number was. You did not have to FOIL it out. It was just one of those things I thought we'd better clarify, because there was a ton of questions on that one. Question?
So, say you did FOIL it all out, and then you add the 26 at the end.
Yes. You could just combine that 26 and whatever number was there.
Yeah, so it would be a -2.
Yeah.
But then, when you have that big thing all FOILed out, could you then factor that back into the X plus 7, X plus 1, and X minus 4?
No, because you would not see what the original, roots were. The only way you, yeah, the only way you get back to the original roots is the idea of guessing the back number and the front number. And this going back to pre-calc days, where you take the constant in the back and you take the leading number and you make every combination of fraction that can make those numbers. So so the back number would end up being a -2, right? It'd be -2 in the back when you add 26 and 28, and there'd be a bunch of stuff, x squared, or x cubed, sorry. And so it would be 2 over 1, right? The back number over the front number. So this could break up to be 2's or 1's, because those are factors in the number 2. The bottom is just a 1. You'd make every combination of number. So with these over the top, these over the bottom, right? And you make every combination, and what you do is you divide those out. So I would have to check plus or minus 2 over 1 or plus or minus 1 over 1, and I would divide these out. Here's the roots that I would need to check. And what you'd have to do is literally long divide or synthetic divide those out of this thing, synthetic divide them out, and that would tell you the other roots.
That was a process, I remember.
Yeah, that's why we do it. Like everything we've done in pre-calc up to now, what we're building, to like putting all this stuff together. Okay, questions with that stuff? That was one of the questions I know that you guys had a lot yesterday, because it's tough, right? I figured some people could figure out the X-intercept idea, but it was clear that we just needed to talk about that. Next thing.
It's a little bit.
Next thing. How do you do it if I were to give you a fraction, and how do you go graph it, right? So this is the second, second out of 3 problems I want to go through. So if I gave you a fraction, let me give you one here. And it doesn't matter the type. Let's say my problem is, let's go x cubed plus 8, and let's go with x squared plus 4x plus 3. I don't know, just making up something. Okay. All right, so let's say this is my function, and it wants you to go graph this thing. So, what I would do first is figure out, does this thing have a horizontal like asymptote? Is it limiting at some point where I can't are the end behavior, like the outside tails, because I always looked at end behavior first, are the outside tails going to flatten against a number, or are they going to go like up and down kind of a thing? So, in my case, we look at the biggest 2 powers. What does that tell me that the biggest power is on the top? Is it going to flatten?
Yes.
Yeah.
No.
The only time it flattens is if the powers are the same, top and bottom, or if the bottom is somehow bigger. That's when it will flatten against a number. The tails on the outsides will flatten. In my case, the top power is bigger, so that means it won't flatten against like a single number, like 2 or 0. It won't do that. In this case, where the top and bottom powers are the same, you take the leading numbers and divide them. So in this case, it would flatten against the number 1. There'd be a horizontal asymptote right here. So that means wherever the tails are, they're going to like flatten out against it. I don't know where they're going. They're not going up or down, they're just going horizontal right there. That's the end behavior. On this case, since the bottom's bigger, it always flattens against 0 when the bottom number is bigger. But in your case, do you agree the powers on the top is bigger? So it's not flattening. In fact, what is x cubed divided by x squared?
X.
X to the first, right? X to the first is what, an odd power? You agree? So where are the tails going, odd powers?
Opposites.
Opposites. One's up, one's down. So I know that's where they're going in the long run. I can tell you, the left side's probably going down, the right side's probably going up. Just normal standards. And again, that's just a rough guess what it's doing. Now, to figure out exactly like the middle of this graph, because there's a lot going on here, and again, I'm merely guessing at this thing. This is just using educated like steps to get me a rough sketch. It may not be perfect, it may not even be like exactly right, but this is doing it without a calculator in my hand. So I'm trying to like guess where this thing's going. The first thing, I'm going to factor the top. How do I factor the top to figure out x-intercepts?
Difference of cubes.
Cube rule. Okay, cube rule, small parentheses, big parentheses.
Same, opposite.
Same.
So
Same.
Same.
Same,
Opposite,
always
opposite, always positive. Now, how I got these x and 2, I just take the cube root of these. Cube root of x, cube root of 8.
It's 2, 2.
Then, what you do in here, you square the outsides, you square these, so it's go here, so x squared and 4. The middle is made by multiplying these 2 together. This looks like a trinomial, it will never be able to factor. Never ever. It just can't. It just, that's the way cube rule works. It just will never be able to factor. Because the number in the middle will be too small or too big. Okay? The bottom's a trinomial. So the bottom is what? Plus plus. They're the same, they're both plus signs. It's 3 and 1, and then I just do x and x. So I factor this thing apart. Okay, so now, what I have to do to figure out x-intercepts. what would make these parentheses 0? -2. And this part, I can never make 0. Because you're squaring it and you're adding a 4, I'll never be able to make 0. The numbers, I'll never be able to do it. So this part, you don't have to worry about it. It's kind of like an x squared plus 2. Like, I will never be able to make it 0, so it only has one x-intercept. It's going to hit at -2. Because you're squaring it. The numbers squares grow too fast, they're always positive, and no matter what you're subtracting off of it, it'll be too big, it'll always be positive. Now, on the bottom, there's a couple y-intercepts. So I had x-intercepts, not y-intercepts, but vertical asymptotes, sorry. So we do have a couple vertical asymptotes that I cannot touch. What would make the bottom 0? -3, -3, and -1.
Wait, we can't touch those?
You cannot touch those because you can't make the bottom 0. You can't divide by 0, so those numbers are thrown out. You can't use them.
That's pretty skinny.
Yeah, it's really skinny. So there's 3 distinct pictures here. There's a picture on this side, there's a picture on this side, and there's something happening in the middle. Okay? And again, I'm merely guessing what this thing is doing. I have no idea. So now what we need to do next, y-intercept, if I even have one. Y-intercept to go to my original props. I've done x, done x, and now what I got to do is plug in a bunch of zeros here to everything. So for the y-intercept, 0 plus 8 over 0 plus 0 plus 3. So it's about 8/3. 8 divided by 3 is 2 and 2/3. Like 2.6 repeating. So 2.6 repeating. So something like that. Okay. So it kind of gives me an idea. Again, the arrows on the outside are just a rough kind of scene where it's kind of going. All right. So, so here's what I'm thinking. So, since this is probably going down over here on this side somehow, and it looks like I'm only hitting the x-axis once. What I'm betting on is it's probably like something's like over here. Maybe it's doing something like this, where I'm not actually hitting the x-axis anywhere. I have to be below it, so I'm thinking like it's probably something like that. I don't know. Maybe it's like maybe it's doing that and it's coming back down. So I don't think it's finding against 0. So something's happening on this side where it's going down, but it's not actually hitting the x-axis. Over here, I think it's doing something kind of similar where it's you know it's going up maybe something like that. It's doing something on this side like on the other side where it's probably going up. Now it could be like reversed anyway, but it's not hitting the x-axis anywhere, so it's probably going up somewhere. And in the middle, there's probably something going on here where it's doing maybe something like this, where it's going through the x-axis. Now again, this is a mere guess because it's not flattening against anything. So I know it's not going towards 0. So it's doing something where it's staying on this bottom half and the top half, because I kind of know roughly where the tails go, but then the middle is crossing the x-axis. So I'm using the x-intercepts, the y-intercepts to help me kind of plot. Am I right or wrong? I have no idea. Like this is literally a guess. When you're doing these, you're kind of putting like the basic rules together. It's not symmetrical. It's because I can tell there's too many things going on here. It's an odd type of graph, so there's some weird stuff going on here. And I'm trying to get a rough sense where this thing's going. And so I'm kind of throwing in numbers.
So like the people like created Desmos, how do they know where it's going?
That's just using straight mathematics, and they're just using the actual graphing calculator itself has been pre-programmed to type in numbers.
Somebody else programmed.
Yeah, and all those programs do is that they type in numbers one at a time, right? It's just kind of like it's not artificial intelligence, but it's like a program where it's just typing one number at a time, and like it's picking from all the real numbers, and it's just spitting out an output. It's plugging in like 2.5, spitting out the output and putting a dot on a graph, and it just plots those dots.
But somebody had to figure out
So,
what the
I see
output
what you
is.
mean.
Could we do that?
It's not somebody pre-programming going, okay, it's going up right now. It's just plugging in numbers one at a time, and it's doing it automatically.
So what you're saying is they'll plug in like
-400, and it will plot where that dot is, and it's just connecting all the dots to make a solid line so it looks like it's drawing.
Like they'll plug in 1.
Yeah, they'll
and
plug in
it'll
1
get
for whatever
9
that's at. They'll
over-
plug in 1.2, 1.4. And it doesn't automatically because they just set up a table and it just plugs in all the numbers.
So is that the actual way that
So-
like humans would solve that?
Yeah. In theory, yeah.
When push comes to shove, I'm on the test and I don't know how to do it the right way, could I do it that way?
Plug in numbers?
Yeah.
Absolutely. You could always do that.
Always.
Or you can just plug in, like, just select two numbers right and left side, and just plot where those dots are, and you can see where it's going. Without guessing like what I'm doing, where I'm just like using basic rules. Right? Alright, so what do I got on the top? Y equals, what is that, x cubed
Plus 8.
plus 8. Now on the bottom, what's on the bottom?
X cubed.
X squared
Plus
Plus
4x.
plus 4x
Plus 3.
plus 3. Alright, and I was pretty much close. Here it is. I went wrong in the middle. My middle's backwards, but I was pretty spot on with where I'm going. So, this part was the only thing I had wrong, was this. I had it going the opposite way than we should. And again, I could have figured that out by plugging in some numbers to kind of see if it was up on the right, down on the right. I just really guessed at it. But by using, you know, the simple like idea of like evens and odds, I was pretty right on the outsides. I knew the outsides were going up and down.
You
So, like,
looked it up.
over
before
right
you
and left.
do it.
What?
You looked it up.
No, I seriously didn't. I made this up on the spot. So, I honestly did. I made it up right when you guys were standing here, so I was sitting there. So, alright, but there you go. The middle I had wrong. It is going like up and then down to the right. But I'm using just basic rules. I can get a really rough sketch what it's looking at without knowing it perfectly.
You're so smart.
So, alright. So that's how I do it. Alright, the last thing that we're going to cover, and I'm not going to do this today. The last thing I want to do is like on Friday, what we're going to introduce is the thing that Brown brought up the other day. And it was it's right in front of me. It was the thing like, how do you know where the peaks and valleys are? We're going to start that process now. We're in that section, that third section now, that we have to learn how to do it. It's not like crazy, it's just one of those things we did it in pre-calc, but we're going to take it to another level. And we have to figure out how to work it.
Is this the
So-
thing with the fishbowl?
What?
And there's P's and there's C's? Is there 1/4 involved somehow? No, what is it? What did we do last year?
We did a lot of stuff actually.
Well, yeah. No, but it was.
I,
You know what I'm talking about?
yeah.
What is that called? I need some vocab words.